On this 2015 to 2025 F150 with the 2.7 EcoBoost, P0013 can point toward a cam timing control concern where the module command and the circuit or actuator response may not line up the way it should. The driver may only see a warning light, or the truck may run rough, hesitate, or feel down on power. Broadly, the possible fault areas can include wiring and connector integrity, power or ground issues, scan tool command and response, oil condition, and the mechanical timing system. Start with the basic system checks first. Make sure the concern is actually present before leaning on any test result. And do not replace modules or other components just because the code is stored if the concern is not present during testing. If other codes are present, check what they mean first. Circuit-related codes come before system or performance-type codes, and if several circuit faults show up together, look for a shared power or ground problem before chasing individual branches. Before getting deep into P0013, do the simple checks in order. Look for any obvious condition tied to the customer complaint. Check for related OASIS or TSB information if it is available, and look closely at any previous repairs because an incorrectly completed repair can contribute to the current concern. Confirm the battery and charging system are operating correctly, and verify battery SOC is greater than 70% before diagnostics begin. Then inspect the harnesses for damage, chafing, and routing. Check fuses, circuits, and connectors for continuity and correct installation, and make sure the related components are actually connected. Continue through the basic engine checks, vacuum lines and air intake for leaks, routing, or restrictions, hoses for damage, leaks, blockage, and routing, fuel quality and fuel system condition, coolant level and quality with the engine at correct temperature, oil level and quality for contamination and maintenance, and the exhaust system for damage, restrictions, and routing. For a cam timing control code, terminal fit matters. Use Rotunda Flex Probes NUD 105R025F or Terminal Probe Kit 418S035 when connecting test equipment or jumper wires to pins, so the terminals are not damaged during testing. Check male to female pin fit with the mating pin and feel for normal separation force. A damaged pin will have very low separation force. If the connector shell, pin guide, or retainer is adding drag, remove the small pins from the connector shell as needed so the fit check is valid. Replace damaged connectors, pins, or terminals. Next, use the scan tool to read PID input values, output states, and diagnostic states. Monitor the PIDs in the data logger so you can see the control system behavior without unnecessary disassembly. Make sure you understand how the system is supposed to operate. Confirm programmable parameters are set correctly for the function in question, and if the structured path points you to a DTC that must be handled first, resolve that DTC before continuing. Test the hardwired and networked inputs before condemning an output. Then test the outputs. Check for module software updates and use output state control to activate components when the test path calls for it. If the module can operate and output normally, shift your attention back to the inputs and the conditions the module is using to make the decision. Avoid unnecessary module replacement. That usually comes from incomplete testing. Also, do not apply power or ground directly to module-switched components with jumper wires unless the test specifically calls for it. When the path points to circuit integrity, load the circuit instead of relying only on a static reading. For a power-providing circuit carrying approximately 200 to 1000 milliamps, load it with a 250 to 350 milliamp test light and measure voltage with the DMM while the test light is connected. If voltage drops under that load, that points to excessive circuit resistance. As a guide, conductor sizes 24 gauge, 0.5 millimeters, or smaller are generally used to carry approximately 1000 milliamps, 1 ampere, or less. For circuits carrying more than 1 ampere, load the circuit with a device requiring similar current, such as a brake light bulb, and again treat voltage reduction under load as excessive resistance. Conductor sizes 20 gauge, 0.8 millimeters or larger are generally used to carry 1 ampere, 1000 milliamps or more. Use voltage drop measurement for higher current circuits. For grounds, measure voltage drop during component operation or attempted operation. If you use an ohm meter on ground circuits, disconnect the battery first. Expect less than 2 ohms for most small diameter 18 gauge and smaller wires, and expect less than 2 ohms of resistance for most wiring harness circuits. Also remember that a standard DMM ohm meter's low resistance resolution, approximately 0.1 ohm, limits its accurate use to circuits carrying less than approximately 5 amperes. When checking resistance or continuity, reverse the leads and compare the readings. If the resistance changes when the leads are swapped, the result is not valid unless the circuit contains a semiconductor. To check for unintended continuity to ground, disconnect both ends of the circuit and measure between the suspect circuit and ground. Resistance should be greater than 10,000 ohms. To check for unintended continuity to another unpowered circuit, disconnect both circuits and measure between them. Again, resistance should be greater than 10,000 ohms. For unintended continuity to a powered circuit, disconnect both ends, turn ignition or run power on, and measure voltage from the suspect circuit to ground. Use back probing only when the circuit has to be tested under actual operating conditions or when a voltage drop method requires it. Back probing is risky because the probe contact can be uncertain and the terminal can be damaged, so do not force test leads or probes into connectors. Use back probes designed for that job. A voltage drop test should show a small amount of voltage, expected to be less than 5% of circuit operating voltage. A 0-volt result during a back-probed voltage drop test can mean the test conditions are wrong, there is no current flow, or the back probe connection is bad. Back probing is not the right method for a single-point voltage check, where 0 volts is a possible result, and it is not the right method for continuity or open circuit checks with an ohm meter. Disconnect and isolate the circuit for those checks. When using jumper wires, always use fused jumper wires. The recommended universal testing jumper wire fuse is 5 amperes or less, unless the load requires a larger fuse. Use flex probes or equivalent with jumper wires to avoid terminal damage, but do not use flex probes to carry high current greater than 5 amperes. For voltage drop measurements, connect the voltmeter at the beginning and end of the suspect circuit, then operate or attempt to operate the circuit so current can flow. A 0-volt reading means bad meter connections or the component is not turned on. A small amount of voltage is normal circuit loss. In 12-volt circuits, normal loss is usually less than 0.5 volts, or less than 5% of circuit operating voltage. Greater than 0.5 volts indicates abnormal voltage loss, and high voltage drop points toward bad wires or connectors causing high resistance. For voltage in, voltage out testing, connect the negative meter lead to ground or battery negative. Operate the circuit, then check the power side and ground side of the load. The power side should be within 0.5 volts of battery voltage. The ground side should be greater than 0 volts, but less than 0.5 volts. A reading of 0 volts or source voltage indicates an open circuit. Keep verification separate from testing. After correcting the fault you found, verify the repair and confirm the code stays gone under the operating conditions that originally made the concern show up. Do not repair a circuit by overlaying a new wire in parallel until you understand what caused the circuit to fail. Find the root cause and repair any adjacent wiring damage too. If the next branch is not clear, pause, recheck the earlier diagnostic path, and avoid guessing. The takeaway is simple. With P0013, do not jump straight to parts. Prove the basics, prove the connectors, prove the circuit under load. Use scan tool control carefully, and then verify the repair. For more diagnostic training, visit stepdiagnostics.com.